How would you keep a standardized record of all operating systems, their versions, the patches they've received, and all other variations that might exist in your network? Take Windows 11, there are thousands of variations in existence. Having a standardized machine-readable way to describe a product becomes very useful when managing those you and your organization are using. The National Vulnerability Database out of America created Common Platform Enumerations, or CPEs, for exactly this purpose. CPE is a structured naming scheme for information technology systems, software, and packages. Let's look at a CPE URI for a product. CPE URIs have 13 parts. CPE at the start, 2.3 represents the version of the CPE framework. So it's always 2.3 at the moment, that's the current version. Then the part, so this is either A to represent applications, O for operating systems, or H for hardware devices. Then we have the vendor part, which identifies the organization that manufactured or created the product, followed by the product, so the most common recognizable title, the name of the product. Then the next part is a version. So this is a vendor-specific alphanumeric string characterizing the particular release version of the product. Then the update, similar to version, so a vendor-specific string characterizing the update, or service pack, for example, in the case of Windows. Then the following 6 parts represent much more specific parts about the software that I won't describe fully here, but they are edition, language, software edition, target software, target hardware, and the final part is an other section which captures generic descriptive identifying information. Now, many tools already use CPE URIs to create software bills of materials, a record of software or products being used by an organization. In the security world, software bills of materials are particularly useful when vulnerabilities are discovered, because network owners can quickly identify if said vulnerabilities affect them. We wanted to represent this link in our research too. The core STIX specification contains a software object we can use to represent CPEs. Instead of having to create these objects each time, we decided to represent the 1.2 million CPEs created by NVD as STIX objects and store them in a database. To do this, the team at DogeSec has created cpe2stix. cpe2stix breaks up the CPE URI to create STIX objects. Here is an example for Microsoft Windows 10. You can see the CPE URI here. cpe2stix has then broken out the vendor, which is Microsoft, the version 10.0, well, you can see how messy versioning can become. The language, the STIX software SWID property contains the NVD match criteria ID. Now this is a useful key for filtering on when looking at vulnerabilities, where CPEs affected by a vulnerability are shown in CVE records using the match criteria key. To make it easy for anyone to get access to the current versions of these objects, DogeSec store the latest CPE STIX records in CTI Butler. In CTI Butler, if I wanted to search for all entries for Windows 10, I could do so as follows. I can then narrow down my search using the other properties, like version, to identify specific CPEs as STIX objects. I'll put a link to cpe2stix and CTI Butler in the description of this video.